Hello everyone, welcome to this video which is a part of playlist where we aim to summarize some really awesome books, and the book we are going to summarize today is Naked Statistic. Yeah, it feels like a book straight out of the academic bag, but trust me, this is one of the best books to understand data. And understanding data, making sense of data is one of the crucial skills in today's world. So maybe let's just go and dive in. So, in the introduction chapter, the author Charles Whelan narrates a funny story where his professor is trying to make him understand how this particular infinite series converges to two. And Charles says that daunting concepts like calculus, infinite series, and even statistics can really make sense if they are understood in an intuitive way. And he gives an example. For this particular series, to understand it intuitively, imagine that you're standing 2 feet away from a wall. And with every step, you're going to cover half the distance remaining between you and the wall. So, step 1, you move 1 foot. That is, now you're standing 1 foot away from the wall. Step 2, you move half a foot or 6 inches. Now you're standing half foot away from the wall. Step 3, you move 1/4 of a foot or 3 inches. Then you do it again and again. Gradually you'll get pretty darn close to the wall, but you'll never hit the wall because by definition each move you take you only cover half the remaining distance. In other words, you'll get infinitely close to the wall but never hit it. And this is what Charles means when he says that this is not a regular statistics book, and the concepts are designed in such a way that they really make sense. The first chapter makes an attempt to help us understand how statistics is actually significant in real life. And let's start with some cases. Imagine that there's a football match going on between Thailand and Argentina, ranked 101 respectively. And it is much more likely that Argentina's gonna win this match because the rank is an indication of strength. Another example, the batting average in one day international for Virat Kohli is 60, which is one of the highest in modern cricket history. This means that Virat Kohli is a pretty damn good player. Or the average household or the per capita income in Singapore is 120,000 US dollars, and the same number is 2,000 US dollars for Zimbabwe. Now this is a stark difference, and it kind of indicates that a resident in Singapore has much more amenities in his life than probably a person living in Zimbabwe. So these description indicators like rank, batting average, or per capita income kind of summarizes really useful information in really few numbers. Similarly, stats can be used to establish relationships between seemingly independent variables, like does the pay affects the attrition, or does smoking causes cancer, or are terrorists generally from a well-educated background? Now, you might say that these questions have an intuitive answer that maybe pay is an important motivator, hence reducing it increases the risk of attrition, or the smoke destroys lung tissues and hence can cause cancer. But what if we had a mathematical backing to it? We had the mathematical significance. And in some cases, this intuitive response might not be there. For instance, like in the case of terrorists and their education background. So these statistical methods, which are going to cover in next few chapters, are really important and kind of establishes the seal behind such relationships. So building on from chapter 1, let us formally introduce some of these concepts to you now in chapter 2. So the first of them is mean, or it's also called an average, but these are technically two different things. We're going to consider them same for this particular chapters. A mean measures the central tendency of a data set. Or in very simple terms, going back to a previous example, when we say that the mean or the average household income of a person in Singapore was 120,000 US dollars, then that means there's a very high possibility that a random person you'd encounter on a street in Singapore would have income very close to 120,000 US dollars. But there's a caveat. Mean or average should never be used in isolation. What do I mean by that? Say, I told you that the average height of a basketball player in USA is 6 foot 6 inches. Now that in itself is not saying anything. Is not enough for me to get an insight out of it. But if I say that the average height of a US person, US citizen, is 5 foot 9 inches, now you have some reference to compare to, and what it says immediately is that basketball players have pretty high heights, and that is mean for you. The formula of mean goes in like this: it's sum total of all the observation divided by the total number of observation. That is, for our per capita income case, it's the total income summed up for all the citizens in Singapore divided by the total population of Singapore. Now let's take a very interesting case. There are four friends sitting in a bar. Their income ranges from 25,000 US dollars to 70,000 US dollars. And by the logic how we defined mean, their average income would be around 50,000 USD. Now say Bill Gates walks into that bar. Now there are five people, and Bill Gates has a net worth, let's say 100 billion USD. And now if I use that same formula to calculate mean, it comes around 20 billion US dollars. And can we say that an average person in that group has a income of 20 billion US dollars? No, because it's due to being Bill Gates there that the mean income has increased drastically to 20 billion. And this is called an outlier. And mean is very prone to outliers and overall gives us a distorted picture. Hence, to help with this, we have another statistical measure which is called a median. And median measures what is at the center of the data set. It is what is the value which exists at the 50th percentile. That is, for instance, let's take this example of 5 people at the bar. You take their income, you sort them in an increasing or a decreasing way, doesn't matter. Then you see what is the value at the middle of that. In this case, it's 50,000 US dollars for C. And by definition, there are as many people above 50k USD salary in this data set as below it. And this is a better description of the picture here. Don't you think so? And while doing this analysis, median offers a better picture and insight to the sample and the data. For instance, the mean salary of a person in India is 45,000 rupees. However, the median salary is 27,000 rupees. That means in India, there are far more people driving the salary, the average, the mean upwards. And that is measured by another economical statistic which is called the Gini index, but we'll not get into that right now. But this is how we are measuring the central tendencies and an overall outlook of how my sample or how my data looks. And that's mean median for you. We'll cover more in the next video, but stay tuned. Part 2 will be coming soon.